Think about the last time you asked an AI assistant for specific documentation, and it gave you a confident answer that was completely wrong. It is a frustrating experience that happens far too often in production environments today. The root cause usually lies in how the system finds the information it needs to answer your question. Most modern systems rely on a pattern called Retrieval-Augmented Generation. This approach works by breaking documents into chunks, converting them into numerical vectors, and storing them in a database. When you ask a question, the system searches for the most similar vectors and feeds those snippets to the language model. Here is the thing. While this method has become the industry standard, it suffers from a fundamental flaw known as the retrieval bottleneck. Vector similarity is not exact, it is probabilistic. Sometimes the most semantically similar chunk is not the most relevant one for the specific context you need. The system might retrieve a document about a deprecated feature instead of the current one simply because the embeddings drifted slightly over time. This leads to hallucinations where the model fills in the gaps with plausible but incorrect information. It also makes debugging difficult because the context window is transient. Once the query is done, the specific slice of context that led to the answer is lost. There is a different way to think about this problem. Instead of treating documentation as a bag of searchable text, we should treat it as a structured file system. Imagine a virtual file system abstraction that allows the AI agent to navigate your documentation just like a developer navigates a code base. This is not about searching for keywords or vectors. It is about resolving deterministic paths. When an agent needs information, it does not ask a database for a similarity score. It asks for a file path. Consider the implications of this shift. In a traditional RAG system, updating a document requires re-indexing the entire chunk or a significant portion of it to update the vector embeddings. This creates a window of inconsistency where the system might serve old data or fail to retrieve new data immediately. In a virtual file system approach, updating a file is as simple as writing to a file. The path remains the same. The content changes. The agent simply reads the new version. This eliminates the need for re-indexing and ensures that the context is always in sync with the source of truth. Now consider the complexity of concurrency. In a vector database, if two updates happen simultaneously, you risk vector drift or stale reads. With a file system abstraction, you can apply standard file locking mechanisms. The agent knows exactly where to write and where to read. It can check for file locks before attempting to modify documentation. This turns the documentation system into a stateful environment rather than a stateless retrieval pool. The agent can maintain context across multiple turns of a conversation by reading and writing to temporary state files. It builds a history of its own reasoning process within the file structure. This architectural change also shifts the role of the human engineer. In a RAG-heavy stack, the engineer often spends time tuning embeddings and adjusting retrieval parameters. With a file system approach, the engineer becomes a curator of structure. You define the directory hierarchy, you define the naming conventions, you define the metadata that maps to file paths. The agent then becomes an operator within that environment. It can create new files to store intermediate reasoning or update existing files to reflect new knowledge. There is a surprising finding in early implementations of this pattern. Systems that use a virtual file system often outperform RAG in production scenarios because they eliminate the ambiguity of semantic search. Deterministic file path resolution is binary. A file exists or it does not. The path is valid or it is not. This reduces the cognitive load on the language model because it does not have to guess which retrieved snippet is the correct one. It knows exactly where to look. This is particularly useful for complex documentation where a specific function or API endpoint is referenced. However, building this layer is not trivial. You need an abstraction layer that sits between the agent and the underlying storage. This layer must handle permissions, ensuring the agent can only access documentation it is authorized to read or write. It must also handle the mapping between high-level concepts and physical file paths. For example, a request for the authentication protocol might resolve to a specific file in the security directory. The agent learns these mappings over time, but the foundation is the file system structure itself. This represents a fundamental trend in context engineering. We are moving from agents that summarize retrieved snippets to agents that edit and create files directly. It suggests a paradigm shift from retrieval, augmented generation, to file system, augmented generation. The agent operates as a developer would, navigating a hierarchy and modifying state rather than as a researcher summarizing text. This improves long-term reasoning and state management because the context is persistent. The file system acts as the external memory of the system, not just a temporary buffer for the current query. The industry is beginning to recognize that the transient nature of RAG hinders traceability and accountability. When an agent makes a mistake, it is hard to trace which vector search led to that decision. With a file system, you can look at the file history. You can see what was written, when it was written, and by whom or by which agent, and by whom or by which agent. This unifies context engineering, shifting human roles from prompt engineers to curators of the system architecture. It turns static knowledge bases into dynamic, queryable environments where the AI has agency over the information it uses. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.